it's common to want the computer to play for some period of time. So, for example, this computer I built is running a simple program that just flashes an LED on and off a few times per second. And the software is pretty
All right,
simple.
let's get
It just needs to turn
started.
the LED on, wait a
Welcome
bit,
back to
and then turn
006.
the LED
Today we are
off,
doing
wait
some
a
of the
bit,
coolest
and
data
repeat.
structures we will see in this class.
And this, of course, is a
some of the coolest data
6502
structures
based
ever.
computer that I built.
Binary
A whole series of
trees.
videos walking through that
You've
process
certainly
and how
seen
it all
trees in
works
many
that you can check
forms.
out on my
They're actually
past,
out in this
including
form of
in
it
some classes
because
I talked to where
when it
trees
drops
are
back to
around
S
school,
or 0
and the decision
or
tree.
X.
But anyway, I've got this LED hooked
But
up here
this lecture and the
to
next lecture,
zero
we're going to build
of port A here.
one data
And that
structure
makes it
that
really
is
easy to turn on.
almost
drops
superior
back
to
to
all
the
data
LED is
structures
off,
we have
which we
seen.
can do by writing
and
a 0 to
can
port
do
A.
almost anything.
We can just increment
really
whatever
fast.
value is on port A, and it'll
First,
turn that
recall
ones place
all the
bit
data
on.
structures we've seen
And
so
then once
far:
it's on,
arrays, linked
decrementing
lists,
port A will
dynamic
turn it
arrays,
off.
You
ordered
have to
arrays.
understand
If
this
we do
what
this
you're doing
in a
though.
loop, then this will
And
flash
the
the LED
two
basically as
sets of
fast as
operations
possible.
we're interested
But
in
of course, it'll
supporting,
be too
the
fast
two
to see
interfaces,
unless we
one
put
was
some sort of
sequences,
delay
where we're
here
maintaining
between
items in a
each of
specified
these
order. We want to be able to
instructions. And
insert
that's what this
an
video
item
is
right
about.
Never
after
good
another
at
item,
doing it
leave
myself,
an item in the middle of the list,
but when you're
and always
actually
be
a
able to access
programmer and
the
you need
ith
to
item.
run
One
loops,
thing we could
figure
do
out
is
how to
see
do
any
this
good
or
data
clean
structures
this
for
up
that problem.
doesn't
because
do anything,
there's
but
We're
this
really
type
good
of
at
trick
inserting and deleting
of
at
two
the
different
beginning
ways
or
of
the
going
end
about
of the
doing
sequence.
this,
But we
and
haven't
you
seen
kind of
anything
know,
that's
oh,
efficient
so the
at
colors and this
inserting in
pattern
the
are real
middle of the
similar,
list.
similar
Reading in the middle of
buzz
the list.
through
Linked
it,
list, you can't
hedge
even
it,
get to the middle.
that's
in
your
less than linear
job,
time.
pack it off, binary
Array, you can
tree.
get to the middle, but if you make any changes, you have to do the
a
shift,
few
which is very
microsecond
expensive.
pause, I guess.
So today,
But for
next
longer pause, we could
lecture,
use,
for the
Spectrum
first time,
a
we
bunch
will
of
see
no-ops in it.
all of those operations
for example,
efficient.
What I'll do is I'll create a subroutine called delay.
Goal.
that we can,
Money round.
delay.
Where efficient
Call it
means
twice.
logarithmic. So we're not quite as good
this way,
as linked lists and
turn
dynamic
on,
arrays
on,
at inserting and
delay for some period of
deleting
time,
at the
turn
ends.
the LED
Those
off.
there we
Engraving
achieve
a glass
constant or
piece.
constant amortized time.
Our loop.
But
So
up to this
really
log
like-
factor,
Like
we're
I
going to
said,
get the
four
best
by
of all
three,
worlds where we
something
can
like
solve
that.
all
We're
the
gonna do a whole bunch
things,
of
Big
no-ops,
ass
right?
all
All we're gonna
the
do is just
operations
have
that don't
A few
build or
spiritual
iterate through the entire
Stephens,
structure. That of
girl
course
with
takes
the
linear
horse,
time.
load the X register with
All the others
angles,
in logarithmic.
the rendering,
Sets,
smoothing
Sets we're
techniques to the meta.
maintaining a bunch of
the
items
decrement
which have
X
intrinsic
instruction, which will
keys,
decrement,
and we
then
want to
branch
search by
that
key.
to delay one.
So hash tables are great
that'll do is
if
it'll-
you're
it'll
only
start with
doing
X
exact
register as
searches.
FF,
You want to find a
and
key
it'll
and
decrement
get
it,
yes or no,
and
is it in there? And if
it
it's
hasn't
in there,
reached
give me
zero,
the
it'll jump
item.
back up here to delay one,
That's
it'll
what
decrement
Python
again. So if you
dictionaries
just put a
do.
no-op
Well, this
in
is
here,
not the
And they're
fancy
great
stuff
at
they
inserting
give you
and
on
deleting.
YouTube for
But they're
marketing.
really bad
But
at
this is the patent
find
design that
previous
you
and
can
find
find out
next.
there
This is
and
the
just
unsuccessful
make it
case. If I
useful for
search for a
yourself.
key and it's not in my
Bend it,
structure,
Ethereum,
I
If we
would
wanna figure out
like
how
to
long
know more than just the
888
answer no. I'd like to know what
MOS
the
chip
figure out
on
how long
the
previous and next items that are actually in the structure. So
decrement, I think, is
what are
also
my nearest
42.
matches when I search my
And,
key?
I
That's
think
a
it's
natural
another letter in
query.
there.
And
We'll see it in a minute.
the only data structure we have that's good at it is a
so we're
sorted
gonna
array,
execute that 255
because binary
times,
search
you can
gives
add
this
all that up to
to
figure it
us.
out,
If
but
we
the
search
other
for a
approach is
key
to
by
just run
binary
the
search
program
and we
see
don't
what
find
does.
it,
I like
the
that
position
approach
that we
because
end up at
it's
is
easier.
right between the previous and next one.
If we get that
But of course,
program
sorted
in
arrays
here,
are
at least
terrible
I'm sure the
for
feeds and speeds aren't
dynamic
exactly
operations.
right.
We don't
And
know
if I
what
go
the
to
LED is just
the
We
poverty
can't
trap
maintain a sorted array
inside
without
of here,
any
you
gaps.
see that learning
It's
curve
Doing insertions
on
and deletions.
step
In some
wave,
sense,
square
today,
wave,
and next
oscilloscopes,
class, binary trees let us
Look at
this
represent
bad puppy
a
right
sorted
here.
order, or in general, an order of items dynamically,
Oscilloscope, I
and
can see
still
it-
allow
it
us to
is,
do
you know,
very
sort of
fast
blinking
things
on and
like
off, if
get
you
at
will.
of I
But the
and
frequency
find
is
previous
This is
and
MIT though.
That's
It's like
our
little
goal.
bobbles are
We're
not
coming
gonna
here to
quite
learn
get
how
to
the
this
first
goal
reactor
today.
went critical
We're gonna
in
get,
America.
See.
The lover's
we
triangle,
can
bobbles
comparable
are getting
thing,
kicked off,
called
close
the
to
height of the
Alamos.
tree.
55, which
And then on Thursday, we'll be
Hello.
able to finish and achieve this goal. Today is just
Let's do
an
that.
Exotic
service
matter is
to-
And for that, we
goal,
can use the Y register, which
Axion.
is easily enough available.
So what is a binary tree?
negative
FF.
2 number. Now what this is getting the Arduino out, figuring out on the first
So we get
step
to the end of the
Find it
of the
precisely.
jump,
Mathematicians will call this a
the
rooted
jump protection
binary
on
tree.
this thing
and then
of the
straight
first
back.
button to get it to go over in a button, a switch.
So that forms an outer
A-
loop.
a
Picture
555.
inner loop that does 255
With those
no-ops,
numbers,
and an
don't
outer
make
loop
sense
that
to you
does
because you're not on this
255
pantry.
times. So that should hopefully create a long enough delay that we'll actually be able to see something.
You're not allowed to, your nose.
Let's give this a try. We'll get that in there.
So this is an example of a binary tree. It has a bunch of nodes, which we're drawing in circles.
Okay,
it has
so that
items
works,
in the
but it's
nodes,
got a
which
couple
I'm writing as
I'm
letters
done.
here. So this is item A, item B, item C.
And we
And it has
we
these
are close.
links between them. This is like linked lists.
Yeah, we have to
but in general,
analyze exactly
a
how many
node,
clock cycles each of these instructions
X
takes and add
is
them
going
up.
to
Glitching
have a
particles.
parent pointer.
You can't If I punch in the face,
left
it's
side
still
child,
a step.
Yeah, so
There's just a different way of
and a
how
right
that's the
child.
same mechanic
And
different.
of course, if the processor were
But-
running,
And it also has
change
an
everything,
item
of course.
inside of it.
The other disadvantage, of course,
So I'm
is
going to
that
talk
while
about
the processor
node.left
is
is a
it
pointer
can't
The
do
to
left
anything
children and the right
else.
the
We
children.
want
left-
to flash an
the
LED.
MIT,
node down
actually,
here,
they do weird
something else.
stuff.
Node.right,
Like,
node.parent,
one of them be a doctor, the
node.item
other one be a lawyer.
gives me
One of them
So
going
the
in the
usually
military,
something
the other one
external
again
look
a
at the
doctor.
node A, its
PhD,
item
going to MIT.
is
And
A.
conveniently enough, we already have a
So
hardware
let
timer.
me
This
draw
6522
for you.
versatile interface adapter chip has got 2 timers built into it. that we can
Examples.
use. You know, so far in my videos, I've mostly just been using these I/O ports, the port A and
Go
port
ahead and
B,
give them books out.
which
I'll
let
do
us
it.
read and write from these 16
do it.
pins here.
You're just
But
all
this
looking
chip has
at
got some other
the
functions.
dot matrix
So
of the
here are all the
math problem,
registers of the
twisted theory in here
6522.
about this
So we've
bin
got the
chip
output
configuration,
input registers.
the
S
parent of
orders,
A
P
is
orders,
nothing.
and
So the
or
data
logic
A is
gates
the root
passing
node.
this
There's gonna
thing
be a
through the
unique
log
node that has
factory
no parent.
200 mile an hour, 2 bar vortex.
Those 2 ports.
Hurricane.
Sad to have
Then
no
we've also
parents.
got, you know, the timer 1.
Then we have
counter,
node B,
low,
which
and
whose
high.
parent is
We've
A.
got a timer 1
Node C
latch.
is
low,
parent. Its parent is A. Node D,
You
its
over
parent
here,
is B.
binary. One
Node
node.
E, its parent is B.
So there are
and
actually
node
2
F,
different
its parent
timers that
is
we can
D.
control using these registers.
Alphabetical
the
order
two
here
timers
happens
have
to be
slightly
ordered
different
by parent.
functions. Timer 1 is a bit more capable for what we're
There it
doing.
is,
Left pointers, I'll just do a
WS65
few of them.
C22.
So
If we
left
look at the top of
pointer
the
of
code here, we'll
A
see where we've
is
got
B.
the registers defined
Right
already.
pointer
Yeah,
of
extra
A.
stuff.
Go ahead and
Maybe
define
do
timer
node.
1 counter low
These should all be
and
nodes.
timer 1 counter high. And those are register numbers.
You could have
4
done it the other
and
way.
5.
I'm circling for nodes and just writing a
Dirty,
letter
just-
for the item.
Everything is
It's
going
clear
to show
that those
up
are different
at
things.
600.
The right pointer for A
Yeah,
is C.
AVE cracks this thing
Left
open
pointer
like
for
it's
B
a
is
Milwaukee.
D.
High registers
Right pointer for B
What's
is
going on
E.
here?
And timer 1 actually has several different modes that it can
So
Like
in
a
other words,
hold
each of
maker.
these
These are set
lines is
using
a
this
bidirectional
problem.
pointer.
register. So
In
there's
Possible-
this direction, it's the parent
impossible
direction. In
word
this
problem.
direction, it's left in this case.
timer control.
Because it's bidirectional, we don't draw the arrows. We
Well,
just draw.
Lord,
auxiliary control
the game is
register,
all going to want to
undirected
pass,
register
and that's
for B.
trouble.
Okay.
So I can find that in the code.
This
as
is in
well.
general what a binary tree looks like.
So those top 2 bits
A
in the
key
auxiliary
invariant
control
is
register
that
mode the timers
if you
in.
take a
And
node
the first one I'll show you
and
is
say
just
go
this
to its
first
left
node where they're both
pointer,
set to 0.
left
Believe it or not,
child,
you stick it out in the
and
woods
then go
like
to
a
that
clone,
node, the
sometimes
parent.
it'll
We
clone.
can actually just set this as
Snap a branch in a
It should
rainstorm,
be
and
the same
it
as
decided it didn't want to
initialization
grow.
code. We've already got a
So
zero
broke far enough off the
Our
tree.
in parent is always
Coming
the
to
inverse
smash
of
with
the
a
left
hammer.
or right operation.
Skynet,
This is also
right.
true for
So
right.
I'll set that to 0. And that puts the counter into
Okay, and that's a
one-shot
binary
mode,
tree. Now,
which is
the
basically a
intuition,
counter.
what's going on here
That means we'll be
is
able to load the timer with
you
some
could
time
say
value
we're inspired by a
and
linked
we'll
list.
Figure out when the timer expires.
Linked list had a very
And this part
similar
of the data sheet
structure.
Here on page
I'm
17
sure
describes how
it was like
to
this
Maybe
product
an
is
item,
monsters,
or
you
there's a
were
node,
accurate.
it had an item in it,
There's
back
the
in the
timer
40s.
one
And it had a
latch
next
high,
pointer,
latch low,
and it had a
timer
previous
one counter
pointer.
high, and timer one counter
So in
low.
some sense, what
Basically,
we're,
the way it
if
works
it's
is
doubly
that
linked,
low
we
and
had a
high
previous
in
pointer. If
each
it was
case
singly linked, we
together
only
make
had
up
a
a
next
16-bit
pointer.
counter. So
And if you
overall,
think
the
about
timer can be set to a
the
value between
limits of
1
linked lists,
and
especially
6,
singly
5,
linked
5,
lists,
which is
if you just have one
the
pointer
highest
per
number
node,
represented with
you can
16
only
bits.
build
And
a
if we're
list.
reading these registers,
And so the result
So,
is,
if you're going to do Aleph
these
1
16
and
bits here,
Aleph,
this latch,
or Aleph
that's
0,
what the
Aleph
counter was
1,
set to.
and
this node
electrons
is going to
alternating
have depth.
and then
direct
the
current,
16-bit
electrocuting,
counter
Depth
tells us where the
means how
counter
many
is,
pointers
so
do I
it
have to
starts
follow
to
to
electrocuting
get
an elephant.
from the root of the
There's,
structure, which
to
for linked
define
list was the
what
head.
infinity
It's doubly
is,
linked. Okay, I can
is
have
the
a head and a
limits
tail,
on these
and I can
things,
have
because
bidirections
even at those
up
limits
here,
we
but
can
then
have
still the middle
divergent
item has
models,
depth
not only
linear,
appear,
so there's no way to get
but
there
when we
in less
know
than linear time.
of
With
that
binary trees,
divergent
because we use
flow of the
two
node,
types
they
of
still
next
divert back
pointers,
to
left
X,
and right.
or they still have this
We
basic
can build a
sequence
tree.
where
We
you
know
go in there to
trees in
hack
general
that.
have logarithmic.
we have some
Can
counter.
have
Getting
logarithmic
here,
height.
make the decision of, oh, so
it's
that's what
possible
this
in a
is,
tree
instead of just
to
looking
get
at the
to
pin chip trying to
any
figure
node
out, oh,
starting
that's
from
what
the
it is.
root and
Or-
only log n traversals.
It says
So
no-
that's the
I
intuition
don't
of
even
what's
need
going
that.
on.
Crack
Now
it open, I just
today,
need this
Counter
chip
is effectively
for
a
something totally different. I'm gonna
We're going to
reprogram
talk
it because I
about
have
the
one of those
height of a
things.
tree.
counter.
Otherwise,
It's
I'd have to know what
automatically
it's doing.
delivering
You get the ones and zeros to do.
the latch. And it says next,
Need a
the
couple
high order
definitions
count
here.
value must be loaded into the high order timer time loaded counter, at which time the value is
Subtree
simultaneously loaded into the
height.
high order latch. So same thing, we can load a value.
I can walk you through the battery and tell you where the fuzzles let out,
so
but much beyond
A
that.
tree decomposes
Go
into
to the-
subtrees.
go to
So, for example, the
recycling
subtree
process will be
rooted
better
at
on
B
some of this,
is
but
subtree
because
of
that
B
actually is what
is
starts
it limits the
this
problem
portion
back
of
down
start
because
tree.
without freedom across the board to be able to
So it's that node and
Copper
all of
or
the
this thing.
descendants of this node. So
So
because we have parents and
pull down the
children,
light.
we
We're
can
dropping
generalize in the
That's
familial
kind of where your
tree
start
sense.
button
We can talk about ancestors of a node. So the ancestors of F are its
We are here
parents,
now.
its
Regression's law,
grandparents,
born
its
in a roll.
great-grandparents,
Yeah,
so on.
original sin.
Together, all of
Not
these
my
are
fault.
called
I didn't do it. We are here. I'm spinning like
ancestors.
this. Let me.
It does a couple
doesn't
things.
quite correspond
So
to
it
familiar
copies
trees
what
because
you're loading
familial
into
trees you have
the
two
high
parents.
order latch,
Here you only have a
as
unique
well as
parent.
copying the contents of the low order latch back down
Or
into
the poor root has no
low
parent.
order counter, as well as actually
We also
starting.
talk about
So anyway, all of that is to
like
say
mixed
that,
metaphors.
as
Leaves
kind of
of
a
the tree.
shortcut, you can almost just ignore this
these
latch
are-
Well,
altogether
if you
and just think,
actually
first
use
you
a
load the
mainline
lower counter
bonsai
with
People with no
plant for
children?
this,
lower 8 bits,
the root is over the
Parents
top
will
for
complain about
the
this.
and then you
the
have higher counters.
universe
You do that.
speed
Many of,
limit here.
like many of us in this room, we have
But
no children yet, so
again,
we are
if you
called
have the
leaves.
bits and bytes for
You
this
can tell your parent, hey,
play
it's the leaf, you
what
know?
they're teaching
Blow it
you,
in the wind.
this becomes
So,
the base system.
there's
You
no
will
other books.
eventually give
It's
you
so many
north,
mixed
south,
metaphors,
east,
but we
west.
always draw
But you're
trees
going to be
downwards,
traveling
starts counting,
like the root
north,
structure of a
south,
tree.
you
and
know.
once the
Yet we call the ends of the
Land,
roots leaves.
Skull Mountain
so,
out
just
there.
upside down. Anyway,
so once this
that's
gets to
trees
zero,
for you.
it'll set this interrupt.
Lots of
and the interrupt flag
entertaining
is gone.
analogies. Okay, but
The
ancestors are
movie.
useful.
Flag
Descendants are also
here,
useful. So the
which is,
descendants of B
registers
are all of
0D.
its children and all of
And
its
if we look at this
grandchildren
interrupt
and all the way
register,
down,
it's got a bunch of
but
bits
just
for different
within
all
the
kinds of
subtree.
And bit
Meta.
6
So
is
subtree of
on.
X
So when that
consists
timer
of
gets to zero,
X
it'll set this
and
bit.
its descendants.
So that's another register we'll need to be able to look at.
Again, you know,
So
when you
that's
do
the
this kind of
interrupt
math
flag.
right,
And we
you're
think
just at
of
the table
X
whether
being
you're
the
there or
root.
not.
Now for the
Of
delay
that subtree.
go
So
down
we're
here
kind of
and
forgetting about
basically
everything
just get rid of all
outside of the
this.
subtree.
And what we're going to replace it with is
X.
initializing that timer value.